Hello folks, this is going to be a big, exciting video. We are speedrunning the first section of the TypeScript docs, the beginner's speedrun. I'm imagining this speedrun being pretty slow, right? We might have to film multiple videos of these. Today we're going to focus on all of the beginner stuff that you need to know before you start with TypeScript. That means all of the basic content that's on the first few pages of the handbook. And we are going to be walking through the handbook piece by piece. And by the end of this video, you should get to a point where you feel confident enough with TypeScript to start playing with it, start messing about, and understand all the moving parts. Okay, let's start with TypeScript for JavaScript programmers. TypeScript offers all of JavaScript's features and an additional layer on top of this, TypeScript's type system. You might think of TypeScript if you've never used it before and think, okay, I have to type everything in order for TypeScript to understand what I'm doing. But that's actually not true. If you hover over hello world here, you'll see it's being inferred as a string. So TypeScript actually does a lot in terms of inferring types from your code. You can define types too using like an interface, and you also see you can define them using types as well. So here we can make sure that this user conforms to this interface. And we do that by assigning a little type just here. So this syntax is your first new piece of TypeScript syntax. If you get it wrong and you say, okay, username instead of name, then it's going to yell at you. And the way it yells at you is by showing a little red line underneath the attribute that's wrong. This doesn't yell at you at runtime, it actually yells at you in your IDE. So why don't we actually go and check this out inside an IDE. So we've got our user interface here, which has name, string, ID, number, and our user is being assigned to the type of user, and it's yelling at us because username does not exist in type user. If I delete this and I try and change it, you'll see that I get autocomplete for the name attribute. And if I remove the ID attribute as well, then I get autocomplete there. Name, John Doe, perfect. By the way, I'm using GitHub Copilot in my IDE, so you might see some sort of suggestions come up from time to time. That's what Copilot is doing. Immediately, TypeScript starts talking about classes now. So we have a class user account. Yeah, you can see like, okay, it's corresponding to an interface here. I would just ignore this. You don't need to worry about this. If you don't like, TypeScript puts its classes front and center in the handbook for some reason. Like, you don't need to worry about this. Like, you don't need to write classes to write TypeScript. But here we go. We can annotate function parameters here. So we can say get admin user returns a user. Okay, I've copied this code in and we can see that it's returning a user, and a function whose declared type is neither void nor any must return a value. Okay, TypeScript, what are you talking about? What it's saying is you must return something from this. So we can return just a string for now. And type string is not assignable to type user. That means you can't pass a user in a slot where a string belongs. So we can say ID 1. In fact, we can just return the user that we had before. That's absolutely fine. It's also giving us a nice overview here of composing types using unions, which we'll touch on later. It even goes into generics here. Okay, yeah, at this point, this is kind of going a bit too deep for where we want to go. I kind of want to start at a more basic level. So here we are, the TypeScript Handbook. The handbook is supposed to be read from beginning to end. But of course, just like a normal reference book, you can dive in and out of various sections. But I really like that they've structured it in this very linear way. So in the basic section, it breaks down the two main types of errors that TypeScript really cares about. The first one is actual errors that will cause runtime errors in your application. So for instance, in this code, we have a message which is a string, but if we try and call it, then JavaScript is going to error. So TypeScript gives you a little red line at that spot where it will error. For instance, if we try and call our user function here, then user is going to say the expression is not callable, type user has no call signatures. You can start to see why TypeScript has this reputation for having these horrible error messages. Like if this just said this is an object, you can't call it like a function, then it would be a lot easier to wrap your head around. But type user has no call signatures can be a little bit hard to read, except that's what it means, right? So often your duty with TypeScript is to try and work out what the compiler is trying to say and then get the rest of the way yourself. And when you've been using it for a few months or 6 months, let's say, then it will become really, really natural. I do actually have a VS Code extension which can help. It's called TS Error Translator, and I'll put it in the description below. What it does is it takes those horrible error messages and it turns them into really nice readable ones. So the second type of thing that TypeScript cares about, it cares about runtime errors, but it also cares about non-exception failures. So let's say you have a user here and you're trying to access the location of that user, except that that user doesn't have a location attribute on it. Now this is not going to error in JavaScript, it's just going to return undefined, but TypeScript still decides to care about it. And that's because it thinks you probably didn't mean to do that. If we check this out in our IDE, we can try and access user.location, but property location does not exist on type user. Not bad for an error message. Very, very good. So that's the second type of error TypeScript cares about. It cares about runtime errors, but also things that break its rules of what it thinks are happening. This means that it can catch typos like this to local lowercase, not locale lowercase. It can also catch functions as well, so functions that you meant to call but you didn't, and many, many other things besides. Another amazing thing about TypeScript is it can do types for tooling as well. So if you're using an external library, even if it's not written in TypeScript, then you can get types for it, so you get autocomplete on libraries you're using. So for instance, here we're using the library express, and we have app.get, and we have res.sen, and it's giving us autocomplete for all sorts of different attributes that we can call on this. This is amazing because it means that you can just autocomplete your way through external libraries without even needing to look at the documentation. Obviously, you can still look at the documentation if you want to, but just having that extra level of safety and extra level of explorability is so powerful. So the way you install it is via npm install g TypeScript. Actually, mostly you'll be installing it locally in your project, but installing it globally is fine as well. You can then call the TypeScript compiler by calling tsc hello.ts. Okay, I'll install TypeScript, and let's run it on our learning.ts file. Okay, so what it did was it produced a learning.js file that's just next to learning.ts. If we compare the two, we can see that we have learning.ts on one side, learning.js on the other. This interface is nowhere to be seen in the JS output. We have a couple of little flags up here like use strict and export ES module true, but really all we're getting is this little runtime thing here. It gets this stripped out of it and it gets turned into JavaScript. So part of TypeScript's job in its CLI is to turn TypeScript code into JavaScript. But what happens if we have a type error in our code and we try to compile? Let's add user.location and let's just try and console log it. Then if we run this again, then it's going to give me an error inside the console here, and it is actually going to compile, oddly enough, because that's its default behavior, but it's going to give me that error and it's going to warn inside the console. So consider this. Imagine that you have your TypeScript application like running in GitHub, and inside a GitHub action, you check your entire application on each commit to see if there are any TypeScript errors. That's how most people have their TypeScript stuff set up. You have your errors in VS Code, but you also have a CI that's checking to make sure that TypeScript is okay on every commit. This is so powerful because it gives you this really strong sense that what you're coding is correct. You haven't made any typos, you haven't done anything stupid. And this makes PRs from your teammates really easy to review as well, because you don't need to go into a huge amount of depth because you know that the fundamentals there are okay. Of course, this doesn't mean like don't review your teammates' code, but TypeScript just gives you a lot more feeling of security. And that's why I love it, for sure. We should talk about strictness here too, because how strict you make your TypeScript compiler, it sort of depends on your config. So here in my project, I have a tsconfig.json. This file has all of the configuration that you need to pass to TypeScript to configure it. And it sits at the root of your project level with your package.json. The main flag I want you to look at is this strict true flag. When you turn this flag on, it turns on all of TypeScript's recommended rules. In other words, its recommended level of strictness. There are even a couple that I would recommend putting on top of that as well. For instance, no unchecked indexed access should probably be true in your project. But if we disable strict, then it's going to be a bit easier for us. It still gives us errors for lots of things. So like location not existing, that still is something that TypeScript can't abide. For instance, if we add this greet function here with strict false, this is not going to give us an error. And what even is this? What am I actually talking about? Well, user here, we haven't given it a type. So TypeScript has no idea what this user is going to be. We know probably just from because we're humans looking at this code that, okay, it's going to have an ID and name, but TypeScript doesn't actually know that. So we can actually access properties on it that don't exist. Now, if we're feeling like conscientious developers, then we can add it here if we want to, and then it will start yelling at us. But by default, it's just going to default it to what's called an any type. And we'll touch on this any type later, but it basically means it can be anything. So I think this is a real code smell in TypeScript applications, because you're basically saying, okay, I give up TypeScript. Like, sure, okay, it can be anything, whatever you like. And for me, this doesn't reveal all of the potential benefits to TypeScript. So a lot of people will say, okay, yeah, just to turn off some rules, like until you get there. If you're migrating a JavaScript code base over, just, turn off strict, it'll be fine. And this is probably true, okay, if you're migrating a massive code base over, you've got hundreds of thousands of lines of code to sort through, then it does make sense to turn strict off if you're okay with that. But for me, part of TypeScript's appeal is the amount of peace it gives me. And if my TypeScript compiler is not as strict as it could be, I'm not going to get that feeling of security. So here are a couple of the rules, like no implicit any and strict null checks that are turned to true when you turn strict on. For me, I'll be turning it back on, thank you, and my no unchecked index access, which we'll look at later as well. Let's look at the everyday types. We start with string, number, and boolean. So string can represent any string, number can represent any number, and boolean is for true or false. Let's play with our function here. Let's say that greet takes in A, which is a string, B, which is a number, C, which is a boolean. And we can greet, yeah, hello, 1 true. If we get this wrong, we pass a string into the boolean slot, then it's going to yell at us. You can represent arrays in TypeScript as well by using this syntax. So if we say that greet takes in A, which is an array of strings, whoops, got the syntax wrong, then it's going to yell at us if we just pass one string, and it's going to be happy if we pass it an array of strings. We can also express an array kind of like this, where we have array string. This syntax isn't necessarily that important now, but it will become very important later. You can think of this syntax as kind of like a type helper, where array is the sort of function that you're passing something to, and we're passing it a type of string which represents the members of the array. If we change this to number, then we can pass in a bunch of numbers here too, and that's all fine. If we get one of them wrong, then it'll say type string is not assignable to type number. This for sure is one of the most common type errors that you're going to get, and it's good that it's kind of nice to read. You might be wondering to yourself, because like GraphQL expresses it like this, why didn't they choose this syntax? Well, this represents tuples, represents a certain number of numbers or strings, whatever. So in this one, we can only pass greet an array which has one member. If we try to pass it a second member here, then it's going to yell at us because source has 2 elements, but target only allows 1. But we'll cover tuples later. Okay, now on to any here. Now, any is kind of like TypeScript saying, okay, JavaScript, I get it, like you're not actually a type-safe language. So if we assign any to greet here, then you can literally pass it anything. You do have to pass it something, but you can literally pass it anything whatsoever. It doesn't matter at all. And inside the greet function, then a dot whatever, it's not going to complain about anything, it's not going to infer anything or autocomplete anything. There's a reason that any exists, of course, because TypeScript is not actually type safe at runtime, and TypeScript doesn't actually help you make JavaScript type safe at runtime either. JavaScript is still JavaScript when it gets to the browser. TypeScript doesn't add anything to it. So any has to be there because JavaScript kind of is like an any language by default. So you should think of any as kind of like an escape hatch for when you need it. And when you're starting out with TypeScript, you should try to use any as little as possible. There are advanced use cases for any. There's some cases where like any is the only thing that can possibly work, and that's why it's in the language. So it has to be there, but you should definitely try not to use it if you're still starting out as a beginner. There's even a lot of teams who use ESLint to make sure that you can't use any in your code bases either. It will give you a little red line when you try to use it. So stay away, you have been warned. Okay, we now get to type annotations on variables, which we've actually kind of touched on before. Let's do it one more time, where we have const mat is a user, and this user, it's all the way up here. By the way, something you can do inside VS Code is you can command click on this user to actually just go to it. So like a find in definition, or go to definition, sorry. And so we have this user ID mat, and this makes sure that if you get this wrong, then it's actually going to show the error here. Property name is missing in type ID. It basically says, okay, Matt is a user. We also have functions here. We've looked at parameter type annotations before. These should be fairly self-explanatory based on the stuff that we've covered, and also return type annotations here too. One thing that's really cool about TypeScript, and I think a lot of the advanced magical stuff wouldn't work without this, is anonymous functions. So if we have an array of names here, we have John, Jane, and Matt, then we can say names.map name, and we don't need to type this function. It knows already that it's a string. It's inferring it just based on the context in which it's being called. This is absolutely badass, and it means that we can even like remap it onto something different and then map it again, and that map, that user there, it will understand that user.id and string are here, and if we remove id, then id disappears from here. Oh, it's just beautiful. Let's talk next about object types. Object types allow you to specify x number, y number here on an object. Object types can also nest other objects as well. Object types are really, really critical to understanding TypeScript. If we go back to our greet function, then we can say, let's say get coords, and we have coords is like x is a number and y is a number. Then we can return, let's say, yeah, perfect. This might look a little bit ugly to you because we're having to like specify it in line, but we can extract this out to an interface or a type if we want to. We can say interface coords and then grab that there, and then also type coords, and this one uses an equals instead. And if I just comment that out, then I can replace this with coords here. It doesn't matter which one I use as well, so interface or type will behave the same here. If you're interested in whether you should be using type or interface, then I have another video which you should check out. You can make an object property optional in TypeScript too. You do it by using this syntax, this sort of question mark colon syntax. We can do this inside of interfaces too, where we can say, you remember the location that we had before, so like user.location, we can actually specify that user.location sometimes exists. So we can say location, let's say it's a string, and then we can give it this, and that will say location, oh, it might be available, might be not. If we hover over user.location, then it's going to say string or undefined. That means it might be available, might not. If we add it to this user, then we can choose to add it or not add it. You know, it's optional. Union types. Now we're getting somewhere. So a union type can be a type that can be either one thing or the other. So in here we have function printID, and the ID is either number or string. If we imagine that our user type over here, it can either have an ID which is string or number, then we can just give that either a number or a string. If we have a function called handleID where we have string or number being passed in, then we can do some narrowing here to work out which one is which. So if we say if type of ID equals string, then we can say, okay, ID to uppercase, and we get all of the methods that usually come with strings. But that means that it's not then a string, it's a number instead. This means you can do really, really cool like control flow stuff here with TypeScript, where you can handle the case where it is a string and handle the case where it's a number. If I change this to number, then this is going to error at me because to uppercase does not exist on type number. Really clever stuff. So unions can kind of represent the branching in your application. If you have a situation where various different things are possible, like you can pass in different members of like an enum or something, and you need to do different behavior based on each one, then this is exactly where union types are perfect. Another great example is like with toArray here, where we can check if X is a string, and if it is a string, then we wrap it in an array. Onto type aliases here. We've sort of covered this already, but let's go into a bit more detail. Type aliases can be used to represent any type in TypeScript. So that can be, union types. It can be object types. Here it can be function types. Interfaces, however, are mostly used for declaring objects. So you can't have an interface that represents a union, for example. That's a thing that only a type can do. Interfaces are interesting though, because they can be extended. So if we have an interface animal here, then interface bear can extend that animal. You see again why TypeScript has this reputation for being sort of object-oriented programming-ish, but it's only because it has these kind of first-class primitives for doing this stuff. With types, they're sort of a bit more function-focused. You can do sort of anything you want there, but you can actually do the same thing really with types and interfaces. Here we have type animal equals animal and honey boolean. This is like an intersection type. We'll cover that later too. Let's look next at type assertions. So type assertions mean you can say my canvas document.getElementById main canvas as canvas HTML element. This as is doing quite a lot of work there. As is pretty powerful in TypeScript because let's say we have this user here where we're saying, okay, this user must conform to a user type. As is a way of saying, okay, TypeScript, I actually know better than you, because we can actually remove properties from this. from this user here. Isn't that weird? So we can actually force something that isn't a user to conform to the user type. This has limits though. So if we have like const name is Matt here and we say as number, then it's actually going to yell at me because conversion of type string to type number may be a mistake. Neither sufficiently overlaps with the other. That means that they're not similar enough for you to actually use them together. So you'd have to do something like as unknown as number if you really wanted to represent Matt as a number. So again, this is one of those features that makes TypeScript a little bit less safe than a conventionally fully typed language would be. But this is because it's based on top of JavaScript, which is itself not safe. Another really common pattern you'll see, which I would not recommend doing very often, is saying Matt as any here. This makes name or turns name into any here because now Matt is typed as any. This is like the classic way to break out of TypeScript's hold on you. And again, I would really recommend not using as any if you're still a beginner, but it is useful in some situations. You can also do this. You can wrap something in parentheses and say user as any blah, 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 blah. This means that even though the user is typed as a user, it's actually going to be typed as any within these parentheses, and then you can access anything on it. Literal types. Ooh boy, I really like literal types. This little const name is Matt here. What do you think name is inferred as? And what do you think it's inferred as if I change this to a let? Well, as a let, it's inferred as a string because I can change my name. I can say Matt is Matilda instead. But if I change this to a const here, then name is actually going to be inferred as the literal Matt. The reason for this is that you can't reassign Matt because it's a constant. So anything that TypeScript knows is a constant actually gets inferred as its literal type. So if I change this to blah, 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 then it's going to be inferred as blah, 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 blah. Or if I change it to true, then it's going to be inferred as true. This doesn't work for objects, of course, because objects are actually mutable themselves. So it understands that name first is string here. And so if I say name.first equals Matt now, then that's perfectly allowed. Whereas if I were to wrap this in something like object.freeze, then it wouldn't allow me to do that because it's read-only now, and it gets inferred as John. Very, very cool stuff. The other thing this lets you do is to basically pass in named kind of enums into the arguments of functions. So imagine we have like a can-perform-action function where the action is like create and then maybe update, and then the entity is like user and post. Let's imagine that. And now we can call this, and when we call can perform action, of course I misspelled it, you silly goose, then I'm going to get autocomplete for these options here for create or update. So if we check if we can create a user, then create the user. Really, really cool stuff. Let's talk about null and undefined. There's a lot of stuff here about strict null checks off or on, but if you're using strict true, then strict null checks is already part of the deal. So if you're a beginner, I just recommend ignoring this stuff. Basically, null and undefined are just some of the values that you can use in these type unions or anywhere else. We can say type my null equals null, for instance. Or say location, instead of it being sort of this or undefined, we can say this or null instead. So string or null. If you want to continue your speedrun to TypeScript greatness, then I recommend looking at my beginner's course on totaltypescript.com. In this speedrun, you've basically just been in the back seat. You know what I mean? I've been driving, just walking you through everything. But in my TypeScript course, it takes you through everything in interactive exercises. You don't get any knowledge for free. You have to go and learn it and earn it. It's been really fun taking you through this first section of the speedrun. And if you liked it, maybe I'll do a few more, perhaps focusing on individual sections. For instance, one on conditional types, one on generics, one on map types, all that fun stuff. So thanks for joining along. You should like and subscribe as well if you've got to the end of this freaking video. Like, this is going to be a long video. But otherwise, I'll see you very soon.